morning, everyone. Today we are here because, as you know, we delivered the first version of the new GSS software. This software is planned to replace the DOS in the next month, let's say. So it basically has all the function of the DOS, in particular data gathering and of products and eviction of products according to specific rolling policy. There is a catalog where data are exposed according to the new Copernicus API or data API. And there is also another component, because the GSS is not a monoblock software, but it is composed by three different components: an ingest, a catalog, as I already mentioned, and an admin API that for this first version is in charge to the quota management. Okay, this is basically the main function of the GSS. I think that I can leave the floor to Rosine for an introduction more detailed about GSS, and then to show you a short live demo of the functioning of this software.
Okay, thank you, Elisabetta. Good morning, everyone. Did you get me well, or there is something missing? Okay, so we can start now. As Elisabetta said, we developed together this solution called GSS, and we will have just a look about the features and go straight to the demo. So you can have here how the components are divided and the functionality that they are managing. So the GSS the ingester, he gathered information, products from different sources, like a directory or a DOS, another DOS, and put them into the stores. And he update also metadata information. In this case, it use Solar system to put the metadata information. And we have also the catalog, which will read, will check the products into the Solar and the data stores too. Here we have two types of data stores in this schema. We can have directory or Swift storage, which is a cloud storage. According to the demand, we have also we can plug also a key clock, which is a IAM, Identity Access Management, which will manage the connection for users. So with all this, we can gather products and search them with a OData classic interface, just like OData. It is the same type of request. So we have just an overview on the roadmap that we are following. Here now we are in THS4, and we develop the ingestion from DOS, GSS, and from cloud storage too. And we can use user authentication, the basic authentication or O2 also, and we can. Yes. Okay. Something. Sorry. So for the next release, we will have the ingestion from the DAS. We will have ingestion from DAS and a configuration using the admin API that we are developing. We will have also the generation of traces for each ingestion. The GSS 6 is the next release. We will have also the deletion from the catalog version of the products. We could find all the code sources on this link. Here it is the presentation of the 1.2.0. This is the version that we will present. We have also a Docker distribution of the system. We need to install some tools before operating the GSS. In occurrence, we have Kafka. This is a distributed event which stream the messages from the producer to the consumer. We have Zookeeper. We provided a distributed configuration and for the distributed service. Solar for the collection of metadata. PostgreSQL for the database. And we can have also a Docker Compose. This is very useful for the deployment. So all these soft installations are detailed on this document implemented by Seiko. Thanks to them. And we have also a kick lock if we enable the identity access management. We can find all the details about the installation and configuration in a different manual. So we will have here we have the presentation of the ingestion. The ingestion as we develop it, as we implement it, is based on the consumer producer paradigm. So the producer use a topic to produce messages, put them in a queue, and we have consumer which read some topics or one or more topics and read the message and process them. We can define some task that the consumer will perform on each message, and according to the configuration, we can have as more instance of the same consumer that we need. This is just to speed up the consuming of the messages. This feature will replace the just synchronizers, and we will see further how it works in more details during the demo, for example. And now, sorry. The next slide I need. Okay. The ingester, as we saw, the producers check from sources the list of the product that they need to process, and we can have many filters. We can define two types of filters on producers. The first filter is on the product name. So we define a pattern which the producer will focus on and check the products which match the pattern. After that, if we have a OData source, we can define also a OData filter, which will just check the products matching this filter. So the producer check all these products and produce the messages with this product. And the products are put into the queue, and the queue process them according to a certain order. and it will read the topics defined for the consumer, for the consumer, and it launch as many threads it needs to read all the message and save all the information, metadata and data, into data stores and metadata stores. I don't know if you have any question at this point. Okay, can go further. We have three main data stores, HFS data stores, which are directory. It's like an NAS. They store the products. We could have a cloud storage too. These are the Swift data stores, and the products are put into containers, a specific container that we define. And we can have also a packaging of products. It is a zip. The metadata stores in our case is Solar to store metadata information, like we know. And we have also a new notion, which is a data store group. We can define many. We can define a group to store many data stores. So the same property or the same behavior will apply to the set of data stores. We have a Swift data store group, which is a set of containers, and we can for this type of data groups we define a mapper, a container mapper pattern for the name. For example, the example give here just say that the products with different type will be stored in different containers. So Sentinel-1 will be stored in CDH S1, Sentinel-2 CDH S2, and so on. We can define here a kind of storage by product type. And we have a second group of data stores, which are the time-based data stores. And here we define the key period for each data store. The period when they will store the products, and after that they will put them into another data store or delete them. It is here where we can define the retention policy for the data stores. This is just an overview of the data stores groups, a representation. So we have a Swift data store group with a pattern, the pattern that we show you on the previous slide. And now we found that each product type are stored in different containers. At the right, we have the time-based data store groups with 3 data stores and different priority to are set for each data store. And here we saw that after a keep period defined, the products are put into the next level of priority of data stores. The top priority is 0, and the less one is in another number. So the data stores are put in different the information are put in different data stores, and after, if there is no order defined, we delete them. But in our use case, into our demo, we will have 3 data stores groups, 3 time-based data store groups with just 1 data store. So after a keep period, they will be the information will be deleted. This is our use case during the demo. And according to the feature, we have also the catalog, and we will see how it works. But it is based on the CSAO data API for the products entity, and we can perform all the requests we have on the DOS. For example, list the products, query by filters, download quick looks, and so on. We will see more after into the demo. And the last point is the admin API. We define here the users quotas to limit the download quota for each user. It could be in number of downloads or in the volume of downloads per hour, for example. With the admin API, we can update, create, or delete a quota. So this is the presentation, the main presentation of the features. I don't know if you have any question before we proceed to the demo.
I would have some. Can you hear me?
Yes.
Yeah. About the data stores. You mentioned the time-based data stores, so that's just like a container. So beneath it, you can have HFS data stores as well as Swift data stores, right? It's just a wrapper, basically.
It's time-based, yes.
Yeah, okay. And another one, because you mentioned the Swift data stores, they're like for the cloud. Is it also possible to set them up, for example, with Docker by oneself? So we have not HFS data stores, but Swift data stores in our own data center?
I don't. So you want to have a.
Yeah, just if it's possible for to set up our own Swift data stores and use them instead of HFS, for example. Just out of curiosity. No.
Not yet. I think it is not planned here.
If I may answer this, you can of course do it. Unfortunately, the only implementation of Swift that I'm aware of that can work in this way comes with OpenStack. So you would have to install parts of the OpenStack cloud, not the full cloud. I think only the data part would suffice. Not sure at the moment what it would mean, but you could certainly do it on your own site.
Yeah. Yes. Okay. Cool. Thank you.
Okay.
That's it.
Thank you. Okay, so we can continue to the demo. I think it's the main weighted part, and let me just stop this sharing and share my. Okay, so here we are. We are already installed. We have a Docker Compose installation, so we can launch the producer. Now, in our case, let me. Here it is the presentation of the configuration file for the producer. We have a database. And we have also, this is the confound ingester. The first ingester will check on Colab, the products from the 7th of May. And also we apply here a OData filter. We will check just the Sentinel-1 products for this ingester. We define also another ingester, which will put the product in a special topic, Colab 2, Colab 2S2 in this case. And we have also a product type that we selected for Sentinel-2. And we have done the same for another ingester for Sentinel-3. This is just the demo for these 3 types of products. So we can launch it and see what's happened. Okay. So if you see in the logs, we are retrieving the products from Sentinel-1, Sentinel-1, another Sentinel-1, and so on. So he's building his list of products to check. and he will perform, he produce the message which are linked to this product. So he, for example, here he produce and save a message, he give an ID and so on, and he's downloading a product from Column 3, for example. Here it is Column 3. And now we can launch the consumer to get these messages. So okay. Okay. So it started directly because there were many messages that was produced. So we see here that he's performing different tasks, and I need to show you the different tasks that we configure, for example, for this consumer. Okay, in the consumer configuration, in this we define data store, particular data stores for quick looks. So the products are not stored in the same directory as quick look. And this is a choice, but we can put all in the same data stores. But here we just want to show you how we can push the configuration. And we have 3 time base as we present during the in the next the previous step. We defined a time-based data store group with a data store inside. This data store is an HFS, and we define here some properties. The keep period, for example, is 600 seconds. Evict reference to evict the metadata information, and evict attach file to evict the quick looks. And the directory is this one into the Docker instance. But we have we have the directory here. We have all the directory defined here for the quick looks and for the products. They are matching to the Docker instances we launch. So we can check or continue to check the ingestion task. The different tasks are defined into the consumer. The consumer is set here. For example, this is the first consumer. He will read into a particular topic. In this one will read column 1 S1 products, and he will perform these different tasks defined here. First, ingest in data stores, and we configure the data stores to where to put the information. We can have more than one. We have the extraction of metadata, the ingestion of metadata into metadata stores, and we have the quick looks, the creation of the quick looks, and we define in each of these ingestion tasks where to put the data. And we will have the source where to check the download, to download the products, because he will download it into these data stores. We have the same for the second ingester and so on. So it is the reason why you have the different tasks. We have this log, for example, to indicate that all the tasks, we define 4 tasks in this example. We can define less or more. And we have all the tasks execute, for example, for this product. We have this kind of logs. And it is performing. So we can check into the catalog how it works, how we can find the products. Sorry. Okay. Oh, I define a key period very, very, very low, 2 minutes for 3 minutes or 4 minutes. So there are many products to evict. We define the eviction on the catalog. So it will perform it. But we can check to our sorry. So here we have the catalog with the products. We have here for at the moment we have 8 products. We can check just one. This one, for example, is 2. Can go and see how it is. Details.
Sorry, Lucine, we can't hear you anymore well.
Okay, do you get me
Now
now?
it's better, thank you.
Okay, sorry, sorry about. Here it is the details of the products, and we can have all the information, the footprint also. And for example, we will see the attached files. And with the attached files, we have the quick looks. We can download the quick look too. Okay. Here it is. So you have here the quick looks, the quick look of this product, and we can perform also some requests on the publication date. Sorry. Here, for example, the 7 or the 8 for. And here you have this kind of request. We can perform another request on the product name. So its name is Sentinel-2. Okay, so we have the MSc L1C products only, for example. And what else? Can download the product. Can download this product, for example. Okay, there is perhaps there it was. I hope that it was not. I will check if it was evicted before I proceed with the. Yes, so many products evicted during the same time. So I have to be more quick. I put a very slow, a very low keep period, so we can see the eviction. But we have also this product. I think it's a bit okay. Oh, okay. Sorry.
Okay, maybe this is a test instance we used to perform tests, checks. So maybe it's the catalog is not completely compliant.
Okay. So the ingester ends are continuing the processing and keep the products, and we can see into our directory that the products are stored. For example, this is for Sentinel-1 products. In this case, we have this one. And we have the quick looks that are stored in a different way. So this is the presentation of the main features that we can perform with the GSS. I don't know if you have more question or something you need to focus on. Hello.
Okay. If there are no questions, I just want to add a couple of note information, let's say, concerning the roadmap that we shared with all the DHR users to familiarize with the application. So I defined some quick tests of ingestion and diction and all data query on the catalog. I shared the activity with you, and to allow you to install and use the GSS without the need to install a local key clock, at least for this first phase of test. So you can use the GSS with the collaborative EM. We already created all the client, all the configuration needed, and shared with you the credentials. So for who of you that are interested in this activity, you can start, and obviously we can discuss better of your feedback and impressions during the workshop of June, the 6th of June. Okay, I will also share the registration of the demo of today for all of you that need to check something offline, and for the user that joined later. I think that it's all. I remain at your disposal for any support if you start to use the application. So please do not hesitate to contact me also via email or via Jira, as you prefer. Thank you to all. Thank you, Rosine, for the presentation. Have a nice day.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye.
Thank you. Goodbye.
Mm.